Yeah. So this patch playing right now was made by one of the students in the class before. Okay, so my name's Jacob Waters. I'm the Synth and DJ Product Specialist with Roland, Canada. I'm going to be doing an introductory course on modular synthesis. Anytime during the course, feel free to just stop me and ask questions. I want to make sure everyone understands stuff before I move on. Also, I only speak English, but we have Vincent here. He's the Quebec specialist, and he's going to be my C3PO for today. So if you have any questions that you want to ask in French, ask to him, or if you don't understand something that I've talked about, then just stop me and ask Vincent. So as I mentioned, this patch here was created by one of the students in the class before he left. I'll mention later, but the best way to learn this stuff is to just start patching. So he just dove in right afterwards and started making some cool sounds. So I'm just going to clear it all out. So before we get started, how many people here have used a modular synth before? So just one? Do you own a modular synth? Or?
No, but I've worked in the studios with one, and I have Arturia microgroups at home.
Oh, okay, cool. All right. So that kind of gives me a gauge. A lot of people are getting more interested in it. I've been traveling all across the country showing this rig, and there's a lot of people coming out to my seminars and things looking for kind of introductory information on modular synthesis because they're looking to get started into it. So this will kind of walk you through the basics and help you get going. So what is a modular synth? It's a synth that's made up of a bunch of separate modules that each do one task. So, for example, there's a module here that just makes sound. That's all it does. Another module that just filters that sound. That's all it does. And then another module that just changes the volume of that sound. That's all it does. So each one of these modules, they just do one small thing. And all these modules, they exist in most standard subtractive synths, like the Gaia, for example, over here on the shelf, has all these same modules inside of it, but they're all wired internally. You can't reconfigure how they're wired. With a modular synth, none of these modules are wired together. You have to use these patch cables. So you use the patch cables to send the sound between each other and to send control signals. And I'll talk a bit later about what the different type of control signals, but you're literally wiring together your synthesizer every time you go to make a sound with a modular synth. And it's obviously a little more complex having to do that each time, but one of the great things is the freedom it provides you, because you can patch this together in ways that you could never do with a standard subtractive synth that's all wired already. So basically your imagination is the limit with a modular synth. And in the past, they've been used a lot for sound design for movies and video games, creating weird sound effects. For example, this top row, it's the System 500 based on the System 100M. And Hans Zimmer has a wall full of this stuff. And he uses it, the System 100M. He has a wall full of it, and he uses it for creating soundtracks for movies. But more and more modular synths are being used in more popular common music to create unique creative sounds. Like I was saying, you can patch it together any way you want. But one of the neat things too is before you even start patching is that you can create a synth basically catered to what you want to do. So this modular rack here, this whole unit is following a specific standard. There's a bunch of different standards out there, but the most common one right now is called Eurorack. And it tells how high the modules are allowed to be and the power supplies that need to be used. So behind these modules, there's cables providing power, and just the voltages used in those power cables are specified in the Eurorack standard format. So as I was mentioning, it's all a standard, and many different manufacturers use it. So as much as I'd like to say everyone should only buy all Roland modules and have an all Roland synth, one of the real neat things with modular synthesis is that before you even start to patch anything together, you start to get your own modules that you want to use from various manufacturers and create a synthesizer that's unique to you and to what you want to use it for. So before you even patch a single cable, you already have an instrument that's unique to you. The potentials for it, no other synth in the world, unless someone happened to pick the same modules, no other synth in the world has the same sound creation potential as you. And then you add in all the variations with patching. As I've been taking this around, I've been letting lots of people patch it. Every time someone patches it, it makes completely different sounds. It's all down to the patching. So a lot of different potential for creativity and unique sounds with a modular synth. Any questions about that stuff before we move on? Yeah?
Yeah, how much would this go for, let's say? Would it be sold separately, or everything's just in one?
It depends. Sometimes you can get, like this top row here, you can get in a complete kit for, I think it's $25.99 Canadian with a case and power supply. Individual modules, they range depending on the modules. The ones here are $400 to $500 depending on the module, and then the bottom one is a whole row is $800. But I mean, it depends on what modules. Some of them are like $100. You can even get stuff, DIY kits, where basically they give you all the parts and you solder it together yourself. The most expensive part on most of the modules is actually the front plate, getting that cut and printed. All the electronics on the back is the less expensive stuff. So if you just order a kit and make your own faceplate, then you can save a lot of money doing that too. So This is one that I've pieced together for going around showing it to people. But really, like I was saying, the powerful thing is that with modular systems, I don't know if I would want to buy myself a whole complete kit like this if it's something that is going to be available for everyone, a kit this size. You see what I'm saying? It would be nice to mix and match different modules and get my own unique sounding system. So as you were asking about the keyboard controlling it, so I mentioned there's different control signals. So the first one I'm going to talk about is control voltage. It's usually shortened to CV. So on the keyboard, it's going to send out a voltage. So if I press this lowest C down here, it's going to send out 1 volt, for example. And then 1 octave up, it'll send out 2 volts. It goes up 1 volt per octave on the keyboard. And that voltage I will send to an oscillator. I'll talk about an oscillator in a minute. But that makes the sound. So then the oscillator knows if it's 1 volt, I play this lower note. If it's 2 volts, I go up 1 octave from that and play that note. So that's what you're using, actual voltage to control the different modules inside. The other thing on the keyboard here, you notice this output called gate. What a gate does is when the key is pressed, the voltage goes from 0 to 5, and then when the key is released, the voltage drops back down. And this is usually used to control an envelope generator, which again I'll talk about later, but you press a key, the signal goes to 5, it tells the envelope generator to start its attack cycle, and then it runs through the whole cycle on the envelope. You release the key, and it tells the envelope generator to start the release cycle. So I'm going to go through now the basic modules that you can find in most synths. There are a lot of different manufacturers out there making all kinds of different modules, but what I'm going to talk about right now is just the basic standard modules that kind of get you started making sound. So what we have here is a VCO, which stands for Voltage Controlled Oscillator. And all it does is it makes a sound. It can make different sound waves, so it can be square shape, triangle, saw.
That's in the Gaia.
Yes. Yep, and I can show you on here. Sorry. So it's a little hard to see with the light on, but we're filming, so I gotta have the light on. But down at the bottom here, you can see kind of a shape like a sawtooth going up and down. That's why it's called a saw. Triangle wave, shaped like a triangle. And a pulse wave. So it's kind of like squares, but it's called pulse because we can adjust the width of those squares too. So now it's, yeah, it's more like a narrow pulse now. But then I can increase it up until it's square again. And you notice while I'm doing that, I'm changing this, and the graph on the top here starts to change. So what we have on the top here is this is the frequency range of our hearing, 20 hertz to 20,000 hertz. And this is the volume this way. So the first spike that you see here, the really big one, that's the note that I'm playing. It's called the fundamental, but that's the note that I played on the keyboard. The rest are called harmonics, and they determine the timbre of the sound. So for example, you notice with the triangle wave, there's not a lot happening up here compared to the others, and the sound is very kind of dull and muted. But if I go to the sawtooth wave, for example, there's a lot up here now, and the sound is very bright, nasally, kind of buzzy almost. That's all determined by these harmonics that are in that waveform. So that's why you'd use different waveforms, but then this sound on its own is usually a little too bright to just use as is. So what usually happens is you send this bright wave shape into a filter to remove some of these harmonics. So I'll show you that next.